What happens after we die? It's a question that has haunted humanity for centuries. Religion and philosophy offer various answers, but what does science have to say? Surprisingly, a new field of exploration has emerged, sitting at the crossroads of quantum mechanics, consciousness, and the afterlife. Quantum mechanics studies the bizarre world of atoms and subatomic particles. Here, the rules of classical physics break down, replaced by uncertainty and paradox. Even more perplexing is consciousness, the subjective experience of being aware. How does our brain generate thoughts, emotions, and sensations? Science is just beginning to scratch the surface. Could these seemingly disparate fields hold the key to understanding what happens after death? Some scientists and philosophers believe so. They suggest that the strange principles of quantum mechanics, combined with the enigma of consciousness, might offer clues about the afterlife. This is a controversial and highly speculative area of inquiry, but one that could revolutionize our understanding of life, death, and the universe itself. Imagine a world where particles exist in multiple states at once, where objects can be entangled across vast distances. This is the world of quantum mechanics, a realm that challenges our everyday intuitions. It suggests a reality far stranger and more interconnected than we ever imagined. At the heart of this exploration is the concept of consciousness. What is it and where does it reside? Is it simply a product of our physical brain, or is it something more fundamental, something that can exist independently of the body? Some theories propose that consciousness is intertwined with the fabric of reality itself, influenced by the principles of quantum mechanics. Could this interconnectedness allow consciousness to persist beyond the death of the physical body? This exploration delves into these mind-bending possibilities. We'll examine the fundamental principles of quantum mechanics and how they might relate to the mystery of consciousness. We'll journey into the realm of speculation, exploring concepts like parallel universes and quantum immortality. Prepare to question everything you thought you knew about life, death, and the nature of reality itself. Having delved into the strange world of quantum mechanics, we now turn our attention to an equally enigmatic phenomenon, consciousness. What is it that allows us to experience the world, to feel the warmth of the sun or the sting of a tear? How does our brain, a complex organ of flesh and electricity, give rise to the subjective experience of being alive and aware? Defining consciousness itself proves surprisingly difficult. It's that intangible essence of awareness, of feeling, of experiencing the world around us and the thoughts within us. It's the difference between simply reacting to stimuli and actually experiencing those stimuli, imbuing them with meaning and significance. While we've made great strides in understanding the brain's physical processes, how these processes translate into subjective experience remains a mystery. We can map neural pathways, measure brain waves, and identify regions associated with specific functions, but the how of it all, the leap from neurons firing to the feeling of joy or the sensation of pain, continues to elude us. This is the heart of the hard problem of consciousness, a term coined by philosopher David Chalmers. It acknowledges that while we can explain the objective mechanisms of the brain, the subjective, qualitative nature of experience remains a profound puzzle. This gap in our understanding leaves room for exploring radical ideas, including the possibility that consciousness might be more than just a product of the brain.
Beyond the scientific quest to understand consciousness lies a deeper philosophical question. What is the relationship between consciousness and reality itself? Does consciousness simply observe a pre-existing reality? Or does it play a more active role in shaping the world around us? The observer effect in quantum mechanics, where the act of observation influences the outcome of an experiment, suggests that consciousness might not be a passive observer. This notion resonates with ancient philosophical traditions that emphasize the interconnectedness of all things and the role of consciousness in creating reality. Imagine a universe where consciousness isn't just a byproduct of matter, but a fundamental aspect of reality itself. In such a universe, our individual experiences wouldn't be isolated events, but threads woven into the fabric of existence. This perspective offers a profound shift in how we view ourselves and our place in the cosmos. While these ideas remain largely in the realm of speculation, they invite us to consider the possibility of a much richer and more interconnected reality than we typically perceive. Perhaps consciousness, like the quantum world itself, holds mysteries that we are only beginning to glimpse. Mysteries that might one day illuminate not only the nature of life, but also the secrets of death and what lies beyond.
Our exploration of quantum mechanics and consciousness has led us to the very edge of scientific understanding. We've encountered the strange behaviors of particles at the smallest scales, and we've grappled with the mystery of how our brains generate subjective experience. But could there be a more direct link between these two realms? This is the question at the heart of quantum mind theories, a collection of speculative ideas that propose a fundamental role for quantum mechanics in the workings of the brain and the emergence of consciousness. While these theories remain controversial and lack definitive experimental proof, they offer a tantalizing glimpse into a reality where the mind might be more than just a product of classical physics. The challenge for quantum mind theories lies in bridging the vast gap between the microscopic world of quantum mechanics and the macroscopic world of the brain. Quantum effects are typically observed in isolated systems at extremely low temperatures, conditions vastly different from the warm, bustling environment inside our heads. However, proponents of quantum mind theories argue that the brain might be uniquely suited to harnessing and exploiting quantum phenomena. They point to the brain's incredible complexity, with its billions of neurons interconnected in intricate networks, as evidence that something more than classical physics might be at play. One of the most well-known quantum mind theories centers on the role of microtubules, tiny structures found within neurons. Microtubules are long, hollow cylinders made of protein, forming part of the cell's structural support system. However, some researchers believe they might also play a crucial role in consciousness. The OR theory, developed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, proposes that microtubules are the brain's quantum computers. According to this theory, quantum computations occur within the microtubules, shielded from the noisy environment of the neuron, and these computations are crucial for conscious experience. OR suggests that consciousness arises from the collapse of these quantum states within the microtubules, a process they call orchestrated objective reduction. This orchestrated collapse, they argue, links the quantum world to the classical world, giving rise to the subjective experience of consciousness. While the OR theory remains highly speculative, it has stimulated much research and debate. It suggests a concrete mechanism by which quantum effects could influence brain activity, offering a potential avenue for experimental verification or refutation.
Quantum mind theories, while intriguing, face significant challenges and criticisms. The primary objection stems from the lack of direct experimental evidence to support the claims. While we have observed quantum effects in isolated systems, demonstrating their presence and influence within the complex environment of the brain remains a formidable task. Critics also argue that quantum mind theories often oversimplify the immense complexity of both quantum mechanics and consciousness. Consciousness is a multifaceted phenomenon encompassing not just sensory experience but also thoughts, emotions, and self-awareness. Reducing it to a single mechanism, such as quantum computations in microtubules, might be overly simplistic. Despite the criticisms, quantum mind theories persist, fueled by the profound mystery of consciousness and the tantalizing possibility that our understanding of reality remains incomplete. The idea that the mind might tap into the strangeness of the quantum world continues to capture the imagination, offering a glimmer of hope that we might one day bridge the gap between the material and the immaterial. The pursuit of understanding consciousness and its potential connection to the quantum realm represents a journey into uncharted territory. It's a journey fraught with challenges and uncertainties, but also one that holds the promise of profound discoveries. Whether or not quantum mind theories ultimately prove correct, they serve as a powerful reminder that the universe is far stranger and more wondrous than we often imagine.
Our exploration of quantum mechanics and consciousness has led us to the very edge of reality as we know it. We've encountered particles existing in multiple states at once, entangled across vast distances and collapsing into definite states upon observation. But what if these strange properties hint at something even more profound, a reality beyond our everyday perception? One of the most mind-bending interpretations of quantum mechanics is the many worlds interpretation, MWI. Proposed by physicist Hugh Everett III, MWI suggests that every quantum measurement, every moment where a particle's state is determined, causes the universe to split into multiple parallel universes. In each of these universes, a different outcome plays out. Imagine a universe for every possible outcome of every quantum event, a vast multiverse teeming with alternate versions of ourselves living out every conceivable possibility. In this view, death itself might not be the end, but merely a transition point where our consciousness continues to exist in a universe where we survived whatever fate met our physical bodies in this reality. While MWI remains a highly speculative and controversial interpretation, it fires the imagination and challenges us to reconsider the very nature of reality. Could our universe be just one bubble in a vast ocean of parallel worlds, each a unique expression of the infinite possibilities inherent in the quantum realm?
The concept of parallel universes, while mind-boggling in itself, takes on an even more intriguing dimension when we consider its implications for consciousness. If consciousness is somehow intertwined with the fabric of reality, as some quantum mind theories suggest, could it be that our conscious experience also branches off at every quantum event? This leads to the concept of quantum immortality, a thought experiment exploring the idea that consciousness might never truly experience death. Instead, as we encounter potentially fatal events, our consciousness simply follows the path through the multiverse where we survive. From our subjective perspective, we would continue to exist, unaware of the countless other realities where our story ended differently. Imagine living life as a continuous, unbroken thread of experience, even as countless other possibilities branch off, unexplored and unknown to us. This idea, while purely speculative and without any direct scientific support, offers a tantalizing glimpse into a reality where death might not hold the finality we often ascribe to it. Of course, quantum immortality is fraught with philosophical and ethical dilemmas. What does it mean for our sense of self if countless versions of us exist, each experiencing a different fate? And if death loses its sting, does life itself lose its meaning and urgency? These are questions without easy answers, pushing us to confront the boundaries of our current understanding.
The strange properties of quantum mechanics, particularly entanglement, have also fueled speculation about the nature of consciousness beyond the individual mind. If particles can be connected across vast distances, sharing a fate that transcends our usual understanding of space and time. Could it be that consciousness, too, operates on a non-local level? Imagine a reality where individual minds aren't isolated entities, but rather interconnected nodes within a vast universal network of consciousness. In this view, our thoughts, emotions, and experiences might not be entirely our own, but rather influenced by and entangled with the experiences of others, both living and deceased. This notion of interconnected consciousness resonates with ancient spiritual traditions and philosophical ideas that posit a fundamental oneness underlying the apparent separateness of the material world. It suggests that death, rather than being an end, might be a transition to a different state of being, emerging with a larger consciousness that transcends the limitations of our individual perspectives. While this idea remains firmly in the realm of speculation, it offers a comforting and awe-inspiring perspective on our place in the universe. It reminds us that we are not isolated beings, but rather part of something much grander and more mysterious than we can fully comprehend. Our lives and experiences, even after death, might contribute to a universal tapestry of consciousness, woven together by the threads of quantum entanglement.
The intersection of quantum mechanics, consciousness, and the afterlife presents a tantalizing but incredibly challenging area of exploration. While the ideas we've discussed spark the imagination and offer glimpses into potentially revolutionary perspectives, they also face significant hurdles, particularly regarding empirical evidence. The very nature of consciousness poses a formidable challenge. Unlike particles in a physics experiment, subjective experience is inherently difficult to measure and quantify. We can observe brain activity, map neural pathways, and correlate certain brain states with reported experiences, but the qualitative essence of consciousness, what it's like to feel joy or see the color blue, remains elusive to objective observation. This difficulty in pinning down consciousness makes it challenging to design experiments that could definitively prove or disprove the role of quantum mechanics in its workings. How do you isolate and manipulate quantum effects within the complex environment of the brain, especially when the specific effects we're looking for are still largely theoretical? Furthermore, the theories themselves are often complex and multifaceted, with interpretations of quantum mechanics like the many worlds interpretation, and concepts like quantum immortality pushing the boundaries of our current scientific understanding. This makes it even more challenging to design experiments that could definitively test these ideas and distinguish them from other potential explanations. Another major criticism leveled at attempts to link quantum mechanics with consciousness and the afterlife stems from concerns about reductionism. Reductionism in its simplest form is the idea that complex systems can be understood by breaking them down into their simpler constituent parts. While this approach has been incredibly successful in many areas of science, critics argue that it might be inadequate when dealing with something as complex and multifaceted as consciousness. Reducing consciousness to quantum processes, they argue, risks overlooking the richness and complexity of subjective experience. Can we truly capture the essence of a Beethoven symphony, the feeling of love for a child, or the awe-inspiring vastness of the night sky by simply analyzing the interactions of subatomic particles, even if those interactions are governed by the strange rules of quantum mechanics? Furthermore, critics point out that even if we could identify specific quantum effects within the brain that correlate with conscious experience, this wouldn't necessarily prove that those effects are causing consciousness. Correlation does not equal causation, and there might be other yet undiscovered factors at play. The debate over reductionism in the context of consciousness highlights the limitations of our current scientific framework. We've achieved remarkable success in understanding the material world, but consciousness seems to reside at the intersection of the material and the immaterial, a realm where our traditional tools and methods might not be sufficient.
As we conclude our exploration of the potential intersection between quantum mechanics, consciousness, and the afterlife, we find ourselves standing at the edge of a vast and uncharted territory. The ideas we've encountered are as mind-boggling as they are inspiring, challenging our conventional understanding of reality and inviting us to consider possibilities that stretch the limits of imagination. We've delved into the strange world of quantum mechanics, where particles exist in multiple states at once, entangled across unimaginable distances and seemingly influenced by the very act of observation. We've grappled with the enigma of consciousness, that subjective experience of being that continues to elude our attempts at a complete scientific explanation. And we've dared to ask whether these two seemingly disparate realms might be connected, whether the principles governing the smallest scales of reality might hold clues to the nature of consciousness and its potential for existence beyond the physical body. Could it be that death, as we perceive it, is not the end, but a transition to a different state of being? Perhaps even emerging with a larger interconnected consciousness that permeates the universe? These are questions without easy answers, questions that push the boundaries of our current scientific knowledge and philosophical frameworks. While the theories we've explored remain speculative and face significant empirical challenges, they serve as powerful reminders of the vastness of the unknown and the limitations of our current understanding. Despite the lack of definitive answers, the pursuit of understanding the connection between quantum mechanics, consciousness, and the afterlife represents a journey of profound significance. It's a journey driven by our innate curiosity, our desire to unravel the mysteries of existence, and perhaps even a deep longing to find meaning and purpose beyond the limitations of our physical lives. This exploration requires more than just scientific inquiry. It necessitates an open mind, a willingness to question our assumptions, and a deep respect for the profound mystery that surrounds us. It's a journey that takes us to the intersection of science, philosophy, and spirituality, urging us to consider the interconnectedness of all things and the possibility that reality is far stranger and more wondrous than we often imagine. As we continue this journey, we must remain grounded in the scientific method, seeking empirical evidence and subjecting our theories to rigorous testing. But we must also be willing to embrace the unknown, to explore unconventional ideas, and to acknowledge that our current understanding of the universe is likely incomplete. The quest to understand consciousness and its potential connection to the quantum realm is a testament to the boundless potential of the human spirit. It's a journey that may never have definitive answers, but every step we take, every question we ask, brings us closer to a deeper appreciation for the beauty, complexity, and utter mystery of existence itself. While the search for definitive answers continues, the very act of asking these profound questions has the power to transform our perspective. By contemplating the possibility that consciousness might be more than just a byproduct of brain activity, we open ourselves to a universe of wonder and awe. We begin to appreciate the interconnectedness of all things, the subtle ways in which our thoughts, emotions, and actions ripple outward, creating a web of influence that extends far beyond our immediate awareness. We develop a deeper respect for the mystery of existence, acknowledging that there may be aspects of reality that our current scientific framework is ill-equipped to grasp. And perhaps most importantly, we cultivate a sense of humility, recognizing that our understanding of the universe is still in its infancy. Just as quantum mechanics revolutionized our understanding of the physical world in the 20th century, so too might the study of consciousness and its relationship to the quantum realm lead to equally profound breakthroughs in the centuries to come. The journey may be long and the answers elusive, but the pursuit itself is a testament to the indomitable spirit of human inquiry. We are, after all, a species driven by curiosity, a species that dares to ask the biggest questions, even if those questions lead us to the very edge of what we think we know. Thank you for watching. May what we do today bring a brighter, better tomorrow. For more interesting content, visit ardells.com, where variety meets in one place.